Hey there guys, here we're going to start working through Edexcel's Sample Assessment Materials A-Level Maths Paper 1. So I know this is going to take a long time to do, so I'm going to do it in 3 parts, 5 questions each. Let's go. Okay, question 1. So the curve C has equation 3x to the power of 4 minus 8x cubed minus 3. Part 1 wants us to find dy by dx. So to differentiate this function, so dy by dx, well, that's going to be 12x cubed minus 24x squared, and the minus 3 disappears. Okay, then we want to find d squared y by dx squared, so the second derivative, so we're differentiating dy by dx. So this is going to be 36 x squared minus 48 x. Good times. Okay, now part B wants us to verify that C has a stationary point when x is equal to 2. So, at stationary points, the gradient of the curve is equal to 0, or dy by dx is equal to 0. Okay, so to verify that there is a stationary point when x is equal to 2, we need to think about what that means. So, if there is a stationary point at x equals 2, then when x equals 2, dy by dx has to equal 0. So let's substitute x equals 2 into our derivative and see that we get 0. So dy by dx is 12x cubed minus 24x squared. So we're substituting 2 into that. So we've got 12 lots of 8 minus 24 lots of 4. Now that is indeed equal to 0. Therefore, there is a stationary point at x equals 2. Good times. Okay, then part C wants us to determine the nature of the stationary point, giving a reason for our answer. So this is where the second derivative comes in handy. If the second derivative at this point is negative, then we're dealing with a maximum. If the second derivative is positive, then we are dealing with a minimum. If we get 0, then we have to get a little bit clever, but I don't think we're going to. So we need to find then the value of the second derivative So d squared y over dx squared when x equals 2. Well, that's going to equal 36 times 4, which is 144, minus 48 times 2. So that gives us 144 minus 96, which is equal to 48. So the second derivative is greater than 0 at stationary point. So it's a minimum. Cool. Okay, question 2. So we got two sectors of different circles joined together. Both are centred at point O. So we know the arc length of OCB is 3 centimetres. We know the whole base length is a straight line of length 12 centimetres, and we also know angle COD is 0.4 radians. Make sure you change your calculator into radians. So, part A wants us to work out the length OD. So that's the radius of the white sector. So we know the arc length. So what we need to remember for part A, arc length of a sector is the radius times the angle of the sector. So r theta. So here, well, we know the arc length is 3. We don't know what the radius is, that's what we're trying to find, but theta is 0.4. So we know 3 is 0.4, lots of r, and if we divide by 0.4, we get r is 7.5. So this length here, OD, is 7.5. Okay, now part B wants us to find the area of the shaded sector AOB. So the first thing that we're going to need here is the radius. So now that we got this length OD as 7.5, we now know the radius of AOB is 12 minus 7.5. So 12 minus 7.5 gives us 4.5. So the radius of the shaded sector is 4.5. We also need to work out what the angle of the sector is. So, in degrees, angles on a straight line add up to 180 degrees. 180 degrees is pi radians. So this angle is pi minus 0.4 radians. Now we need to remember our formula for area of a sector. So area of a sector is 1/2 r squared theta. So the area that we want is going to be 1/2 times 4.5 squared times pi minus 0.4. Chuck that into your calculator and we should get that is 27.8 centimeters squared. Question 3. So a circle has equation x squared plus y squared minus 4x plus 10y is equal to k, where k is a constant. Part A wants us to find the coordinates of the centre of the circle. So to be able to do that, we need to complete the square on the x terms and the y terms. So, first of all, let's reorder this a bit. Let's say we've got x squared minus 4x plus y squared plus 10y, and that is equal to k. So now we've got x squared minus 4x, so we want to write that as x minus 2 squared, and then don't forget to take away that 4 that we get by squaring the minus 2, and then we're going to have add y. Okay, and then part C wants us to state the range of possible values for k. So when they say the range, that's a nice little clue that an inequality is going to be involved somehow. So remember, the equation of a circle in general is x minus a squared plus y minus b squared is equal to the radius squared. So k plus 29 here is the radius of this circle squared. What that tells us though, most importantly, is that k plus 29 has to be positive. It has to be greater than 0 because it's a length squared, so it has to be positive. So k plus 29 has to be greater than 0, so that tells us k has to be greater than minus 29. Question 4. So, given that a is a positive constant, so I'm going to write that down straight away. A is greater than 0, and the integral between a and 2a of t plus 1 over t with respect to t is equal to log 7. We want to show that a is equal to log k, where k is a constant to be found. Okay, so basically we want to find this integral, see what we get, set that equal to log 7 and solve for a. First of all though, we need to split t plus 1 over t into two separate terms. So t plus 1 over t is equal to t over t plus 1 over t, which is 1 plus 1 over t. So our integral has become the integral between a and 2a of 1 plus 1 over t with respect to t. So let's integrate that then. So 1 integrates with respect to t to t. So we get t, and then 1 over t integrates to log t, the natural log of t. So we get t plus log t between a and 2a. So let's calculate that. So that is 2a plus log of 2a minus a plus log a. So don't forget, everything in the second bracket is being subtracted. So we've got 2a minus a. So that's going to give us 1a. And then we've got log of 2a minus log of a. Now, by our rules of logarithms, remember log 2a minus log a can be simplified to log of 2a over a. So this is equal to a plus log of 2a over a. So that is a plus log 2. So that is our value for the integral. Now remember, up here, we were told the value of the integral was log 7. So we know a plus log 2 is equal to log 7. So a is log 7 minus log 2. We can combine that to log of 7 divided by 2. So a is log 3.5. Now remember, we were told that a is equal to log k, where k is the constant to be found. So our final answer is therefore k equals 3.5. Question 5. So we got some fun with parametric equations. Good times. So curve C has parametric equations. X is 2t minus 1 and y is 4t minus 7. Add 3 over t where t is not equal to 0. Our mission is to show that the Cartesian equation, so the equation in terms of x and y, is of the form y equals 2x squared plus ax plus b over x plus 1, where x is not equal to minus 1. And a and b are integers to be found. So what we want to do here is use one of the parametric equations to get t on its own, either in terms of x or y, and then substitute that into the other parametric equation. So looking at them, it's the x one that's going to be a lot easier. So first of all, if x equals 2t minus 1, we're going to rearrange that to get, well, x plus 1 is 2t, therefore t is equal to x plus 1 divided by 2. Now we're going to substitute that into the second parametric equation, y equals 4t minus 7, add 3 over t. So we're going to sub the expression 4t into y. Okay, so we can say y is equal to 4 lots of x plus 1 over 2 minus 7 add 3 over, so minus 7 add 3 over x plus 1 over 2. Okay, so 4 lots of x plus 1 over 2 would cancel down to 2 lots of x plus 1. So we've got 2x plus 2 minus 7. Now remember, when you divide by a fraction, you flip it over and multiply by it. So 3 over x plus 1 over 2 becomes 6 over x plus 1. So let's sharpen that up a bit. So we got 2x, then 2 minus 7 is minus 5. So we've got 2x minus 5 add 6 over x plus 1. So what we now need to do is write this as a single fraction. So what I'm going to do is put this first lot of stuff in brackets, and I'm even going to put a fraction line with a 1 on the bottom. So to combine fractions like this when we're adding, we're going to do the bottom of the second fraction times the top of the first. So that's 2x minus 5 times x plus 1, and then whatever the sign in the middle is, so here we're adding, and then the bottom of the first times the top of the second, so that's just add 6, and then it's all over the two bottoms multiplied together. So it's all over x plus 1. Okay, so what we need to do now is expand out these brackets on top. So 2x times x is 2x squared. Then we're going to get 1 lot of 2x minus 5 lots of x. So that's 2x minus 5x. So that's going to give us minus 3x. And then we would get minus 5 times 1 is minus 5. And then we've got this plus 6 at the end. So we're going to get plus 1. And then that's all over x plus 1. So now we can say that a is minus 3 and b is equal to 1. Good times. Okay guys, that's enough fun for part 1. Hope you found it useful. Let me know down below in the comments. Give us a thumbs up, get subscribed, and I'll see you in part 2.